In this lesson, you're going to learn how to combine different types of functions and what happens when you combine these different types. So let's start with the first type of function, which is a linear function. Recall that a linear function increases or decreases at a constant rate, and an example of a linear function is something like f of x equals 4x plus 3. Now you have this other kind of function, which is called exponential, and exponential functions are nonlinear. The defining characteristic of a nonlinear function is that they do not have a constant rate of change. So that means I'm going to write down here nonlinear, and what that means is not constant. Whereas with the linear equation, you have a constant rate of change. And when I write constant or not constant, it's with respect to the rate of change. So an example of an exponential function, it has the general form of f of x equals b to the x, but an actual concrete example would be the function f of x equals 2 to the power of x plus 4. So let's try a problem together. For the school fundraiser, Lucy and Xavier each sold the same number of coupon books for $20 per book, and they each received donations. How much money did they raise combined? So there's some extra information you need to know about this, okay? Lucy received $84 in donations. So Lucy's donations totaled 84. Now plus, so this is the total amount of money she raised, right? $84 in donations plus $20 per coupon book. And we'll let the book represent X here, or X represent the number of books she sells. So for Lucy, you have 84 plus 20x. Now let's talk about Xavier. How much did he receive in donations? Well, Xavier received $45 in donations, and he sold the same number of coupon books, so you would have the same term here, 20x. So let's just define these as functions. So Lucy will be f of x, and that means f of x equals 84 plus 20x. And then Xavier will be g of x, and g of x is 45 plus 20x. Now we want to find how much they raised combined. So both of these functions are linear. What we can do is add the two functions to find the total amount of money that they raised. So let's just write these together. It would be 84 plus 20x plus 45 plus 20x. Now what you can do is combine like terms. You've got the two constants here, 84 and 45, and then you've got the variables of 20x plus 20x. 84 plus 45 is a total of 129. 20x plus 20x is a total of 40x. So that means altogether they raised 129 plus 40x. Now if you had to, you could separate this out, and if you were asked how much did they each receive in donations, or what was the donation total, they received $129 in donations. And if you wanted to find the total amount of money they raised by selling the coupon books, you would find how many books they sold, and then you would multiply that by 40. Let's try a problem involving linear and exponential functions. Sing It or Wing It, a new singing competition show, is airing soon, and 81 contestants will compete in the first round. The competition is set up so that 27 contestants advance to the second round, then 9 contestants advance to the third round, and then the final round has 3 contestants left. The other piece of information that I want to include here is that the number of contestants in each round is represented by the function f of x equals 81 times 1/3 to the power of x. Now the first round, okay, let's think about the first round. First round is when x equals 0. So that means the second round is when x equals 1. So let's use this formula and just test it out. So you have f of x equals 81 times 1/3 to the power of x, and we're going to check how many contestants are in the second round, which is when x equals 1. So we're going to raise this to the power of 1. When you evaluate this function, you get 27. So this means that 27 contestants should be in the second round. So let's see. The competition is set up so that 27 contestants advance to the second round. Okay, so cool. This confirms what we see in the information from the problem, and we know that the formula is behaving as it should. So let's try and figure out something different. Let's see what happens when, let's say that 3 contestants drop out. So if 3 contestants drop out, I want you to write the equation that would represent the number of contestants in any round if 3 players dropped out. If one player dropped out, right? If just one player dropped out, we would represent this as the function g of x equals 1. So this is one player dropping out, or one contestant. Now, if 3 of them drop out, I would write this as g of x equals 3. So we have g of x equals 3, and we have f of x from up here in red, which is f of x equals 81 times 1/3 to the power of x. I'm going to erase this example. Okay, so we've got two functions, g of x equals 3, f of x equals 81 times 1/3 to the power of x. If 3 players dropped out, you'd want to subtract the function. So you would have f of x represents the number of players in any round, minus g of x, the number of players that are dropping out. So this will give us a new function, which we're going to call h of x. So h of x equals f of x minus g of x. So let's fill in the values. F of x equals 81 times 1/3 raised to the power of x. And g of x equals 3, so minus 3. This equation right here for h of x represents the number of contestants in any round if 3 players dropped out. Let's take a look at another problem together. Okay, so here we have a graph of 2 functions, and we want to know, how do the 2 functions compare to one another? First thing to note is that you see these curves here that are very indicative of exponential functions. So we're going to compare 2 exponential functions. Now, one of the functions we're going to call f of x, and it's labeled right here on the graph. Here's f of x. So let's just write the equation out a little bit more clearly. F of x equals 2 times 4 raised to the power of x. And then let's go in here and find the other function. Here's the second function. This is g of x, and we can write that one out. G of x equals 2 times 4 raised to the power of x minus 6. Now both of these functions are labeled on the graphs as well. And something I want to point out is that g of x is the image of f of x after a shift of 6 units down. So what that means is that this red curve here, or this curve that's on top, is translated down 6 units and we get to g of x. That's really how these two compare. If we want to go a little bit further, the graph for g of x has a different y-intercept than the graph of f of x. And you can notice that. Let me just highlight those points for you. So here's the y-intercept for f of x. It looks like the y-intercept happens at y equals 2. Let's go down here for g of x. You see that it crosses the y-axis at a different point, which looks to be about y equals -4. So g of x is the image of f of x after it is translated 6 units down, right, in this direction. And the other difference is that they have different y-intercepts. In this lesson, you've learned what happens when you combine 2 types of functions. Happy solving!